Hi everyone, this is Himanshu, and in this lecture, we will study about the ITER. So, the ITER, the first one that we're gonna discuss, ITER, that is basically the International Thermonuclear Experimental Reactor. Now, the ITER is actually a fusion reactor. So, let me write it here in the points that you would remember. So, ITER is a fusion reactor that works on the basis of the tokamak approach. Tokamak approach. So, what generally happens at such high temperature, the hydrogen gas is in the plasma state, where the electron and the nucleus are not bound, and thus difficult for the ordinary container to hold the hydrogen. So, thus, what happened that under the tokamak approach, the magnets are used. So, here the magnets are used to confine hydrogen as long as the nuclei are in the motion. So we use here the magnets to confine the hydrogen, as long as the nuclei are in motion. And as a result, this method is also sometimes called as magnetic confinement. So this is a basic principle behind the ITER and how it works. So if you look for the further details, then ITER first started in 1985 and it is in the France. And more importantly, it is a joint collaboration between the multiple countries, and which also include the China, India, USA, Japan, Korea, etc. So all these are there, and it is designed to produce the 500 megawatts of the fusion power from the 50 megawatt of the input heating power, and it will be completed by 2025. So this is mainly about the ITER. The next one that we're gonna study is basically the cold fusion one. Now, as we have discussed earlier, the cold fusion is actually achieved by keeping the hydrogen cold. So the one way to get the fusion without requiring the high temperatures is to cancel its electrical charge. And we need to remember that high temperature is actually required only to overcome the electric repulsion. So always remember that whenever we heat something, the only the aim behind the heating is to overcome the electric repulsion. So here, this is done by making a particle with a negative charge stick to the hydrogen nucleus. So generally what happens when a negative charge stick to a hydrogen nucleus, it cancels its proton charge. And this electrically neutral nucleus can then get close to the another hydrogen nucleus. Then the nuclear force brings the two nuclei together in a fusion. So this is the main procedure of the cold fusion is. So if you want me to explain again, then you need to rewind it back and you can listen to it again. So in order to do this, the hydrogen or the deuterium, so we can say the hydrogen and deuterium is made to react with the palladium is there, one of palladium, zirconium and nickel at a very low temperature, because these metals are actually also called as the soakers. So this is the reason why the cold fusion is also called the low energy nuclear reaction sometimes. So here it is also called as low energy nuclear reaction. So showing short LENR. So this is a general principle behind that. And the India's Bhabha Atomic Research Center, the BARC, has recently restarted the research into its 25 years after it was shut, and it is actually the base on the cold fusion reaction. So this is mainly about the cold fusion and the ITER. In the next lecture, we will discuss about the India's nuclear sector, the three-stage nuclear programs of India. So let's jump to the next chapter. Thank you, guys.